additive synthesis. When you're trying to make a sound that, when you listen to it, sounds like an oboe or something. This is the way you kind of conjure that up, by taking various overtones and combining them at different frequencies. Okay, so how about the right-hand side? Well, the right-hand side is cosine 4x, right? In terms of x. Oh, okay, so we got to zoom in on this, huh?
You
So
waited for
34.
34.
Oh, I said 34? I was wondering why it was so large, or such a high frequency. Somehow I hit a 3 by accident there. Okay, that's more like it, huh? But still, we kind of want to zoom in on this, right, so we can see what's happening here. So what are these points of intersection? Well, we see, can we say options advanced? On the x-axis, I want to look at, what about the x-axis? I want to scale by multiples of pi. Oh, here, x-axis, I think I can say units of pi. Okay, so then, yeah, so this is pi here, right? So we can kind of see what's half of pi. Well, that looks, I don't know. Pi over 6, where's pi over 6? Well, if that's pi over there, this looks like pi over 6 here, huh? So pi over 6, 4 times pi over 6, what's that? 2 pi over 3? Right, and that's one of our solutions. So the cosine function. So let's go ahead and plug that in. Where pi over 6, comma, I guess I want g of pi over 6? Either one, I guess. But yeah, that's that point there. So it's not obvious that that's a point of intersection, is it? I don't know if we zoom out on that. I really kind of have to look carefully at this to see that, yeah, they're kind of very close to each other in that interval, but they intersect at pi over 6. And what's that other point there? Well, when theta equals pi over 8, 4 times that is pi over 2. Cosine pi over 2 is 0, right? So get another point, so we can plot that point as well, right? So let's plot the point pi over 8, comma g of pi over 8. And there's that point, right? So that's another point of intersection. What's the next one there? Is that 5 pi over 6? Looks like it, huh? Well, maybe not, huh? Oh, I zoomed in more than I thought. So if I zoom out again, can I do that? It's not going to let me, huh? Nope, you can't do that. Your zooming rights have been rescinded. Okay, there we go. So where's pi? Okay, pi is way out there. So this is pi over 8, that's pi, that's 1/8 of the way there. So what's this one here? So that's 3 pi over 8. That's the next one, right? So if I plug in 3 pi over 8, I get cosine 3 pi over 2. That's also 0, right? So apparently the left side is 0 as well. So if I were to say, give me the point 3 pi over 8, and f of 3 pi over, it doesn't matter. Either one, they intersect there, right? 3 pi over 8, so they're going to be the same. And that's that point. Point C. That's another point of intersection. And what do you suppose the next one is?
5.
Yeah, I think it's going to be 5 pi over 8, right? Is that, or wait, which of these is bigger, 5 pi over 8 or 5 pi over 6? 5 pi over 6 is the bigger one, right? So the next one is 5 pi over 8. And let's plot that one. So I've got 5 pi over 8, f of 5 pi over 8. There's that one. And so this one must be 5 pi over 6. Well, this one here, actually, right? So let's plot that one. So if I have 5 pi over 6 and f of 5 pi over 6, there it is, right? There's that point. Right? So these points at A and E are pi over 6 and 5 pi over 6. And the next one must be 7 pi over 8. And so on, right? So I suppose we could zoom out and see. Yeah, between 0 and 2 pi, you know, there are how many points of intersection? 1, 2, 3, 4, 5. 6, I guess, and the one that's 0 is not a point of intersection, right? But pi, we do get a solution. Oh no, I'm sorry, there's no solution at pi. What are you talking about? No. All right, so altogether there's 10, right? So we get 5 between 0 and pi, which is A, B, C, D, E, and there's another 5 between pi and 2 pi, which are pretty much similar kind of points, right?
Anyone before?
Oh, no, because you have the one at 13. The rest of them are going to be over pi over 8, and there's only 2 for over pi over 6, because they don't intersect in part.
Oh.
And they're probably going to repeat after 2 pi. So they're going to repeat every.
So you have a
pi.
great advantage over your grandparents. They couldn't. Maybe your parents could do this, but
No.
they have access to it, I think.
Oh.
I mean, the technology existed. I mean, basically, graphing software became available to students when I started teaching,
When did you
in
start?
1942.
I think
Okay, 1989 was when I started here, which I was at Glendale and Pasadena before that. But, and there we did have, it was like the Apple Lisa had graphing software on it. Remember the Apple Lisa? No? It was before the iMac and everything, right? Between the Apple II and the iMac, I guess, there was something called the Lisa. So in any case, let's take a break and more trigonometric equations.